Okay. We are back in business. I am so very sorry, y'all. Okay. Homework. This is what we were talking about. Also, the Google thing is gone. So maybe there was a bug. Maybe I had a virus. I don't know. I have no idea. I know nothing about a computer. All right. But what I do know is that we are ready to go. Okay. So on the first one, number 19, you have a number line. Okay. Your number line is H and J, and it just says K is between. It doesn't say that K is the midpoint. It just says between. So then what we're going to have right here is X minus 5, like so. And then we're going to have 5X minus 12 right there. And the whole thing is 25. All right. So what we're going to do is we are going to do the segment addition postulate. So I take the little pieces, X minus 5, that's little, plus the other little piece, 5X minus 12, and set it equal to the big. Then you solve for X. Okay? Anybody want to see me solve for X? Are y'all okay with that? All right, over here for 20 though, this one is the midpoint. So you've got A and you've got C, and B is your midpoint. So it tells us that AB is X plus 6, and the entire thing is 5X minus 6. Okay, so can I, or how am I going to do this? Good, because there are going to be two of these, because whatever this is, that has to be the same thing because it's the midpoint. So you've got 2 times X plus 6 equals 5X minus 6. So you're doubling that smaller piece and then setting it equal to the entire thing. Okay. Now 21 says point P is between points F and G. The distance between points F and P is 1/4 of FG. Remember that? We talked about that being multiplication. What you need to know is the distance from F to G. So what is that distance? Good. It's going to be 16. If you do the absolute value difference, which is what I'm showing, that gives you 16. So we need 1/4 of 16. So what is 1/4 of 16? 4. Okay, so that's 4 units from F. It says the distance between F and P is 1/4 of FG. So I'm going from F forward 4 units. So where's that going to place me? At 8. So 8 is P. Okay, 22. Anne has broken a ruler. It starts at the 3-inch mark and ends at the 12-inch mark. Explain how Anne can use the ruler to measure the length of the line segment in inches. What can she do? Good. Okay, so you could just subtract out the missing part. So just take away 3. What else? Anybody else have a good idea? Okay, so just like in your mind, make 3 be 1 and then 4 be 2. And yeah, you could definitely do it that way. Or you could do the absolute value difference. But all those ways that you guys just said are fine as well. So you just would do the absolute value difference and say 3 minus 6 if it's there, or 3 minus 7, and then do the absolute value difference, and that would work as well. 23. If P is the midpoint of ST, SP equals X plus 4, and ST equals 4X. Determine the length of ST. Okay, So 23, we know that this is S, we know that this is T, and P is the midpoint, okay? So it says X plus 4 is SP, and we know that ST, the entire thing, is 4X. They want you to determine ST. So again, how am I going to solve this problem? That's right. You got to double that X plus 4. So we've got 2 times X plus 4 because that's the smaller piece, and then set it equal to 4X. For this one, you're going to solve for X, which does anybody know what X is? It's 4. Okay, so X equals 4. So you'll work it out, solve, 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 X equals 4. But that's not the answer. How do you get the answer? That's right. So you take this ST and you plug in 4. So what's 4 times 4? That is your answer. 16 is your answer. Okay? All right, and then it says compare and contrast a postulate and a conjecture. I'm just going to read you what the book says so that you can see exactly what they're trying to say. All right, 24, it says a postulate is a statement that is accepted as true without proof. A conjecture must be proven using deductive reasoning before it can be accepted as true. Okay, so postulate is just accepted to be true without being proven, but a conjecture must be proven. Okay? All right, cool. All right, so what time is it? It's 10:06. So we're going to get as far as we can through this, but more than likely what I'm going to have to do is just record 4th hour when I do this again and upload 4th hour's video. So we will see how far we can get, and then we'll just make a decision on what we're going to do, okay? All right, so look at page 45. .45 is about angles. We're going to be talking about applying the angle addition postulate to find angle measures and then using the definition of angle bisector. So it's very similar to kind of what we were talking about with segments, except for this time we're going to be dealing with angles. So I'm going to be moving quickly so we can get through as much of this as we can. This that you see here is a protractor. Okay, I don't require you to have a protractor for this class. I know on that first diagnostic it made you use a protractor, but when you take your EOC, if they want you to use a protractor, it will be digital. Okay, so we may do some Khan Academy practice with protractors, but if you use one this year, it will be on a computer. Okay, if you want to have one just for fun, go for it. So this is a protractor, and when you read a protractor, you can go both ways. You can read here from 0 to 30 and know that that angle, EOD is 30. Or you can read on the inside, okay, and that one is 50. So you're going from 0 to 50. Or if you're looking for this angle here, what you would have to do is do just like we did with our segments and just look at, you've got 50 over here and 90 over there. So you would take the absolute value difference of that, and that would give you your degree. So if we look at the first one, they've got AOB. Okay, so AOB is here, and they're saying that's 50 because this mark is at 0 and this mark is at 50. Okay, then we've got BOC. So B is at 50, C is at 90. So what is that?
40.
That's 40 degrees. Okay, AOC. AOC. What's that? That's 90 degrees. Okay, EOD. That's 30 degrees. BOD. Where's D at? Oh, I messed it up. There it goes, is this one, BOD. Okay, so you're going from, what's that, 30 to 130. So yes, 100. Good, John. The next one is BOE. Good, because we're going from 0 here all the way to 130. So that's 130 degrees. Everybody okay with reading that protractor? Cool. All right. Now, below that, it says, use the protractor to determine this measure. Well, we're not actually going to do that. We're not getting out the protractors because of coronavirus. But when you do that, what you're going to do is there's a dot on your protractor. You line that up, line the dot up with the vertex. So the dot on your protractor lines up with that, and then you can read that. Make sure that this is at the 0 mark, and then you would be able to read to get to that measurement, okay? All right, so since we can't do all of that, well, actually, I'm just going to tell you this so I can teach you the postulate, okay? So this one is 115. This one is 24. This one is 139. So if we got our protractors out, that's what we would find. So you just add those to those. It says, using the results for item 1 and 2, describe any patterns that you notice. What do you notice when we're looking at 1 and 2? That our smaller angles do what? Can be added together to get the larger angles. Okay. 4 says, given that point D is the interior of angle ABC, describe how to determine the measure of ABC without measuring. If you are given the measures of A, B, D, and angle DBC. Okay, so this is kind of like we could just draw something similar to that. And we're going to say this is A, this is B, this is C, and it says that D is the interior. That's not D. D is the interior. Now, if we know the measure of angle A, B, D, what would we do with that in the measure of angle D, B, C to get the angle A, B, C? You would add them. That is where you get the angle addition postulate. And it works just like the segment addition postulate. If you know the big angle, then you would just subtract down the smaller angle, and that would give you the other one. So literally, this is exactly the same thing, except for instead of dealing with a segment, we're dealing with angles. Okay? All right, so flip that page so we can do a little bit of the math. All right, look with me at number 5. It says use angle addition postulate and the given information to complete each statement. Okay, letter A. If P is the interior of XYZ, what that means is, and you don't have to draw these out every single time, but you can. What it means, if P is the interior, then it's on the inside of that larger angle, X, Y, Z. Okay. So it says that XYP is 25 and PYZ is 50. So what is the entire angle? If this is 25 and this is 50, what's the whole thing? 75. You're just adding those together. If M is the interior of RTD and RTM is 40 and RTD is 65, then what is MTD? All right, let's look at it. We got M is the interior, RTD. Okay, so RTM is 40 And RTD, the whole thing, is 65. How do we get this inside piece right there? You have to subtract, because you know this slice of pizza, you don't know that slice. So you've got to do 65 minus 40. That gives you 25 degrees. So in that one, we were looking for one of the interior angles, one of the smaller angles, not the larger angle. So if we wrote that out with angle addition postulate, we would say RTM plus MTD equals RTD. So it gets kind of tedious writing those out, but you could definitely do that. What you're looking for, though, is that when you have the smaller angles, they should share that interior letter. Okay, so with this one, the M is the interior. So we've got RTM, MTD. Those two small angles together equal the large angle. Okay, C. C says if H is interior of EFG, it's just easier to see it. Okay, so we've got EFG, okay, and it says that who's the interior? H. All right, then it says EFH. EFH is 75 degrees, and FEG is 10x. And the whole angle is 20x minus 5. How are we going to set this problem up? Perfect. And I know that some things are in degrees and some things are in numbers, but when you write out your equation, everything's just normal, okay? So don't stress over who has a degree sign and who doesn't, because if you look, they're saying everything is in terms of degrees, so it kind of just makes it normal, all right? So what we're going to do here is we're just going to combine like terms. I went this way, which I don't typically do, just to keep it positive. So now we have 80 equals 10x. Divide by 10. What's x? 8. So x is 8. Now they want to know what is the measurement of angle HFE. Well, that's right. This represents the angle 10x. So we've got 10 times 8, which means it's going to be 80 degrees. Okay. D, lines DB and EC intersect at point F. If the measure of BFC is 45, BFC is 44, sorry, and the angle AFB is 61, okay? They want us to determine all of the other missing parts. So looking at AFC, that's the whole thing, AFC, how are we going to determine that? You just add them together. You add the two smaller pieces to get the larger piece. So what's 61 plus 44? What is it? 105? Okay. Now we're looking for AFE. How are we going to find AFE? That's right, because these are supplementary. Okay, those are supplementary angles, which means they form a straight line. So we already know that this segment here is 105. So we just are going to do 180 minus 105, which gives me 75. Everybody okay with that one? And then the last one that we're looking for is EFD. EFD is this small angle there. So, and 61. Because he's again thinking straight line right here, which is great. That's totally fine. But you've got to take away this one, which we just found is 75, and this one, which is 61. Okay, see, we would do 180 minus 75 minus 61, and that gives you what? That gives you 44, which another way to do this thing is they told us that these lines intersect, which means their opposite angles are going to be congruent. So if this one's 44, the one that touches on the nose directly across is also 44, okay, because they are vertical angles, okay? So that's just another way that you could do it, but this is a good way to think about it too, being 180. There's usually with geometry, there's more than one way to do most problems, okay? All right, so then we have page 46, the middle of the page, says the bisector of an angle is a ray that divides the angle into two congruent adjacent angles. For example, if line segment BD bisects angle ABC, then angle ABD is congruent to angle BCD. So just like with segments, just dealing with an angle. So look with me at number 6. Okay, it says that a ray AH bisects MAT. Okay, bisects means it cuts it directly in half. So we need to find the missing values. If MAT is 70, if the whole thing is 70, what is MAH going to be? If our entire thing is 70, it's been cut in half by the bisector, so it's going to be half of 75, which is, half of 70, which is 35. So the bisector cuts it in half. If HAT is 80 degrees, then what is MAT, the whole thing? 160, because it's double that. So the bisector is going to split it in half. So if you know one of the smaller ones, then you would double it. If you know the entire thing, then you cut it in half. All right, page 47. 47 says you can use definitions, postulates, and properties of algebra to determine the measure of angles. Example A. If ray QP bisects angle DQL, the measure of angle DQP is 5x minus 7, and the measure of angle PQL is 11 plus 2x. Determine the measure of angle DQL. All right, picture. We need a picture. So it bisects it, which means it cuts it directly in half. And I mean, you can draw whatever angle you want, guys. I'm just sketching them out. So we've got D, Q, L, and then this is P. All right. So then we know that DQP is 5x minus 7. And we know that PQL is 11 plus 2x. Now, what can we do with those bits of information? You could add them together if we knew the whole thing, but we don't know the whole thing. They equal each other because this is a bisector. So you set them equal to each other, solve it out, that gives you 6. They don't want x, they want to know what the angle is. So then they plug in the 6 for both of the smaller angles, which is kind of silly because if you know one angle, then the other one has to be exactly the same. But anyways, they did it so you could see that they're both 23. Then to get the whole angle, they just add the two smallers together to get 46. Make sense? Just like with a segment. It's just like with a segment. Okay, so here we are on try these A. Okay, I'm going to try my best to get through one of these. So we've got angle AFM. Okay, we have a bisector and it is FL. So it wants us to determine the missing values. So we have LFM is 11x plus 4. And then we have AFL, which is the whole other segment, the other little piece, which is 12x minus 2. So how do we solve for x? That's right, because those two are going to be congruent because it told us that it was being bisected. Now this one I think is probably going to be different over here. So if we do this one, we're still dealing with the same situation, right? We've got AFM, and the inside is what, L? So they told us the large angle, the whole angle here, is going to be 6x minus 2, and that one of the interior pieces, y'all can go. I'm going to keep teaching for you virtual people, okay? So AFL is going to be 4x minus 10. Perfect. So you've got one of those little pieces there. So what you can do is you can just write it twice because you know they're going to be the same. And then you would set it equal to the 6x minus 2. So you've got 4x minus 10 twice because it's been bisected. It's there twice. And it's going to be equal to the 6x minus 2. From there, you're just solving it out. Bye, y'all. So you've got 8x minus 20 equals 6x minus 2. We subtract 6x. 2x minus 20 equals negative 2. Add 20. 2x equals 18. Divide by 2. X equals 9. So we were able to get x equals 9. Then we can plug it back in. It wants to know what is the measure of LFM. Well, you know that is what represents it, 4x minus 10. So I'm just plugging in the 9. And you know that's going to be it because it has to be the same as the other piece. So 4 times 9 is 36. Minus 10 gives you 26. So 26 degrees. Okay, if y'all need to go to one of your other classes, you can go, but this is my planning period, so I'm just going to keep teaching this so I can post this video, okay? All right, so number 7, it says the measure, or angle A and angle B are complementary. So what does it mean to be complementary? Well, corner or 90 degrees. So it tells us both of those together, and then it wants us to figure out each measure. So we know that this 3x plus 7 plus 6x plus 11 has to equal 90 because they are complementary. So then you combine 9x plus 18 equals 90. Subtract 18, 9x equals, is that 72? Divide by 9, x equals 8. So that is your x, but it wants to know what each measure is. So I'm going to plug in for angle A. So angle A is 3x plus 7. I'm going to do 3 times 8. 3 times 8, that's 24. 24 plus 7 is 31 degrees. Now, if that's 31 degrees, you could plug in and do the other one, or you could simply just subtract from 90. So what's 90 minus 31? Well, that's 59 degrees. Okay, so the measure of angle A is 31 degrees. The measure of angle B is 59 degrees. Okay. All right, let's see what's on the next page. I think we're almost done. Yeah, this is just to check your understanding. Let's do number 8 for sure, and then we can look at that, and then y'all are ready for your homework. So number 8 says, in the diagram at the left, you see line AC is intersecting line BD. Okay, determine the measure of angle CEB. So CEB is this angle here. Now remember that the angle across from it is going to be congruent. So these two things are going to be the same. So if we could figure out what angle DEA is, then we would know what angle CEB is. So what we do know is that together, those two angles form 180 degrees. So I'm going to take both of those, combine them, and set it equal to 180 because they are supplementary. They form a straight line. So when I combine right here, I've got 14x plus 68 equals 180. I'm going to subtract out 68. So 14x equals 180 minus 68, which is 112. Divide by 14. So x equals 8. Now, again, I need to know what this angle is. So I'm going to plug in for its vertical angle, the one that's directly across from it, and that is going to give me the answer. So we've got 40 plus 68, so that's 108. So our answer is 108 degrees. All right, number 9. Ray KN is the angle bisector, which means it cuts it in half, of angle JKL. Explain how you could find the measure of JKN if you knew JKL. Well, this is the whole thing, so you would take half of it. Okay, if you know the whole, take half of it. If you know half of it, double it, because the angle bisector is going to cut it in half. Number 10, in the diagram, the measure of angle 1 is 4x plus 30. The measure of angle 3 is 2x plus 48. So we've got 4x plus 30 and 2x plus 48. Okay. Now remember, these are directly across from each other, the ones that touch on the noses, so those are going to be congruent. It goes on to say, write a step-by-step explanation for an absent classmate on how you would find the measure of angle 2. Well, since you know that those two are going to be congruent to one another, you could set them equal to one another and solve for x. Now, this is just one way. I can think of another way that you could do it as well, but I'm just going to go with this one because this was my initial thought. So that equals 18, divided by 2, x equals 9. Well, then I'm going to plug that back in. 2 times 9 plus 48, which is 18 plus 48. Okay, so 18 plus 48 is 66 degrees. So if this one, if angle 3 is 66, together angle 2 and angle 3 have to equal 180 because they are supplementary. So if this one's 66, we need to figure out what is going to help us equal 180. So I'm just going to subtract 66. So 180 minus 66 is telling us that this is going to be 114 degrees. So to recap what I did, I set those equal to each other because they are vertical angles. I isolated x, plugged x back into either of them, 1 or 3, it doesn't matter. They're both going to give you 66. Take that 66, subtract from 180 because they are supplementary. Number 11, and you can kind of see that over here. What I just told you, they're vertical angles. They touch on the noses. I will always talk about them touching on the nose. Okay. Number 11, last one, it says angle RST is adjacent to angle TSU. Remember, adjacent means that they are side by side. Doesn't necessarily mean they have to be supplementary or complementary. It just means that they share one of the rays. So it says that RST is 40 and TSU is 50. Explain how you can use the angle addition postulate to show that angle RST is a right angle. Well, if they're going to be right there together, let me just draw a right angle. Okay, so we have RST, that is 40 degrees. Then we have TSU, that is going to be 50 degrees. Well, they want us to prove that they're a right angle. Well, what you do is you take the smaller angle plus the smaller angle to equal the total angle. So that total angle is going to be 90 degrees, which means it's going to be a right angle. Okay, that's it. We are done. Your homework is on page 48, and you are doing problems 12 through 16. Any of my virtual people have questions? All right, y'all have a... Wait, go ahead.
When will we see what we made on our test?
Wait, say that again.
When will we be able to see what we made on our test?
It will probably be at the end of the day today. Before I leave, I have plans to release your scores to you. So it's my planning period right now. I plan on looking at it, and then I will get that to y'all sometime today.
Okay, thank you.
Uh-huh. Anything else?
Thank you, Ms. Cole.
All right, y'all. Y'all have a great rest of the day.